you can go ahead if you want to. That's fine. I'll get there in a second. But all right, so here's where, nope. Here is where we were yesterday. Now, this wording is a little bit different than what I did with y'all because I hadn't gotten to those others, and like I was kind of doing it on the, thinking off the top of my head, and I think I left something out, but I could be wrong. So look at what you wrote. That it's quadratic because the y values increase and then decrease. I'm not sure I put to a max at. Now, this is not one of those questions that, like this, I think maybe I left out. Maybe not. But this is not one of those questions that you're going to have to put out an exact explanation on. Some of them would be very, very specific. This isn't necessarily one of those. I just wanted a specific explanation here to kind of reinforce what's actually important here. So I want you to have more in there. You can kind of add it wherever. Increase to a max at about 1.7, because we talked about the fact that we don't know for sure that this is 18. I mean, it could be, but not necessarily. So at about 1.7, it should be around there somewhere. Then they decrease, and then the other part of that is that they're roughly symmetric. Okay, so you can kind of amend that if you need to a little bit, because I don't remember exactly what I wrote, but... Right? So then we should all have them typed in, right? And so once it's typed in, you can hit your little magnifying glass. I'm going to leave this up here for a second because I can see some people writing, but hit your little magnifying glass. Go ahead and hit the regression model if you want. So hit my magnifying glass so it makes it a decent window and I don't have to worry about it. But remember, if you see something like this, this doesn't guarantee that it is quadratic, because it could come up and go down and then come back up and be, cubic or something like that. But based on the data they gave us, the best we can do is quadratic. So we hit this, which is nice because we don't have to type in that nonsense. And they give us, that says linear because that's a default. That it's not going to give you the best one. It gives you linear every time. And clearly it's not the right one. But quadratic. But here's the problem. Your answers have to be correct to how many decimal places? 3. And I like to write down 4, but it has to be correct to 3. 3 decimal places here, 2 here, 3 here. Now, it's possible there are only 2. Definitely a possibility. And when I did this one the first time, I thought, well, there's probably only 2. But that's not true. Here's the thing. We got College Board telling us what we have to do. We have Desmos being embedded. They are not the same company, but they're working together. Desmos really doesn't care what College Board says because they do their things their way, right? And I doubt that kind of thing is going to change. So if you know you're supposed to have decimal places because it's obvious, and you don't have, I'm going to add some more so y'all can see what I'm doing, and you don't have 3, you want to double check to see if maybe it is just 15.96 or maybe it's not. So these little 3 dots right here, if you click those, it shows you the regression equation, but then you have this export model to expression list. And then this form is really like if you had typed in this thing here like you had back in the day, this is what you would have seen. And you can see that that's not 15.96. You would get that wrong. It is 15.958. It's actually 15.9580 because there's more after that, but it doesn't matter. That's 3 decimal places. That's all that really matters. So take this information and let's write the equation. We would get y equals, well, I just let you write it down and you're not talking and we can check them. All right. What questions do you have? You good so far? All right, so it's really nice that they put that little regression thing in there to help you. I'm going to give you, while you're finishing that up, you can let me know if you have questions, but I'm going to give you the second page of notes that we're going to go through here. Okie dokie. We all good on this one? Yes? Okay. So this one's also going to go on page 46, I think. That's what it is. So this says the wind speed, x in meters per second, and power. So the relationship between the power output of a wind turbine and the wind speed is roughly cubic. Like it's telling you things right here, right? An engineer collects the data on power in kilowatts generated by a wind turbine against the wind speed measured in meters per second seen above. The data in the table can be modeled by the cubic regression function, and it gives it to you. So here's the good thing about FRQ2. It's going to start almost exactly like this. And it's going to tell you what kind of function it wants you to use. All right? And so you don't have to figure that out. It would be a non-calculator type of question where, and probably multiple choice, or definitely multiple choice, for you asking like, what would be the best model, that sort of thing. But we know it's supposed to be cubic. We don't have to guess. So if on your on your screen there's next up there, I think it says next. Click next, and then it'll say notes number 4. Yep, there you go. And then type in this table here. And I saved mine because I did not want my I didn't want to type it in because that thing hates me, so I'm going to sort of cheat. And when I typed in this data, especially because I was using that stupid keyboard, and I was double checking, or before I started double checking what I typed in, when I just glanced at it, I felt like I'd done it all backwards because it I don't know, in my mind anyway, the Y values look more like what our X values usually look like we put in nice, pretty numbers and get weird. And so I was like, great, I did it all backwards. But I didn't. So, don't second guess yourself and then mess it up. So we get all that typed in. Are we good? And then you can hit the hourglass if you have, apparently I already have, not the hourglass, the magnifying glass. Apparently I already did. And that's what we should look like. And then we can hit regression. Default is linear. If I go to quadratic, it actually looks kind of decent, right? Does quadratic make sense for the situation? No. I mean, because it shouldn't be going back up over here because this is how the wind increases. So that makes absolutely no sense. But it might make sense from, 9 on or something like that, depending on your domain. Exponential looks semi-decent, right? But do we have to decide? No, because it told us, right? What did it tell us? Cubic. Do you see cubic here? No. Cubic and quartic are two that we have to know how to do that aren't on here yet. I'm pretty sure I can add a yet on that. Because this wasn't on here at all when they announced that this was going to be on the AP exam. And then I think some people freaked out and they put this on here. Why those two are missing, I don't know. But I would imagine that they're in the process eventually be added. But we're going to just work on this like, what if they don't? What if the test was tomorrow and we still had this? Because it's really not going to be that bad. So hitting regression really doesn't help me here because none of those apply to me. So I'm going to X that out. If you recall, because I think you've all done regression in Desmos, it might have been a hot minute, but you've done it, that your X and Y had to have subscripts on them, right? So what I would do, for myself especially, is they gave me this. This is almost exactly what I need to put in there. But I need subscripts of 1 on all of my variables. A, B, C, and D are not variables. They're constants or coefficients. Just the X and the Y. And then I also am not going to use an equal sign. I'm going to use the squiggly. Okay? That makes sense? And then I think, so somebody taught me something second period. And then third period, I was like, I don't know, I might be teaching you something or I might not. And I think some people knew and some people didn't. So I might wow you in just a second because I know y'all are better at Desmos than me because you've used it more consistently. So we're going to type this in. So let's type a Y. And so then oh yeah, see this stupid thing. Okay, there we go. Now, so then my question was, do you know how to put a subscript? And everybody was like, yeah, because I think you do. But in the way I did it, and the way I think half of my third period did, you do the underscore, right? If you hit underscore and then it drops it down, you don't have to do that. All you have to do is type a 1. I don't know if you knew that, but I was like, shut up, that's a lot easier. But that's not necessarily true maybe in all platforms, like if you did it in something other than Desmos. Just know if you ever need a subscript, not the dash, but the underscore was what you need. All right, so then you do the squiggly. Then you're basically just typing what you have on your paper now. A times X. I would do the subscripts before the exponents. It's going to make it easier. We're going to put a 1 there. And then do your little caret top to get the 3. The 3. There. And then to get out of the exponent, your arrow to the right. And then you need a plus sign. Then you have B times X sub 1 squared. And keep going. Plus D. Okay? Everybody with me? Everybody good? And I think I can scroll some more. Quartic is the other one that's not on there that we might need. And again, it will be on your, like, in the question. But if not, it's basically this, except you'd have A times X sub 1 to the 4th, and then B, and then you keep going, and then D would have an X sub 1 on it, and then you'd have an E. Like, it just, the polynomials are kind of all the same. And so then here's your A, B, C, and D, and we need to write the equations. So go ahead and write your equation down. Oh, I am writing the wrong thing. Sorry, I'm looking at the wrong part of my paper. Okay, that's what I got for my equation. Any questions about that? Are we all good? Yes? All right. So then it says, based on the model found in part A, determine the wind speed at which would result in an output of 268 kilowatts. Now, they were nice and used this word output. So when I ask you what's the output, or if this is input or output, it's kind of obvious, right? So so that means that here, y equals 268. And I want to know what is the x value when y equals 268. So I come back over here, and in the next blank here, I'm going to just type in what we just wrote down. Y equals 268. Bam. And then where they intersect, that's your answer. When y is 268, this is your x value. So we can come over here and say that x equals 21.6526. And what would the units be? Meters per second. And how do you know? Because it says so, right? But it says right here, but it also in the table, most of the time they're in the table. So you know you're using x, use those units. You don't have to overthink it. And so then meters per second, and we are done. Well, I don't know why I put it 2 meters per second. Okay. Everybody good with that? Okay. I forgot. I wanted to show you one other thing on the last one. I guess you could go back. You don't necessarily have to go back to yours, but let me just open this. Okay. Well, I don't know why it's not doing this now. Either way, it seems like in the other class period where, there we go. Oh, Oh my goodness. Okay. This was the one where I said, is the maximum 18? This is number 3, but you don't have to look at yours. You can just look at mine. And we're like, it should be close to 18. We don't know. It could be more, it could be less. So when you see this, you can see that gray dot. I don't know if you can see it from where you are, but like that is the maximum because it'll just not, mark it for you. And then, so it's just a little bit more than 18, like 18.033. But just wanted to remind you, because when we did maximums and minimums, we did them on the calculator. But if you just kind of drag things along, it plots it for you. Or if that point wasn't so close to it, when I did that, it would just bring that up. But since it is close, if I do that, then it works. Okay. All right. So then, computer's down. Don't close them all the way. Just whoop. And we're going to look at residuals. I think it may say in there, like your next window might say notes number 5. We don't need Desmos for it. So that one should be blank. And then the next window would say worksheet number 1. And then that's where we're going to go for that. All right. But anyway, because you don't actually need a calculator. It shows you a calculator, but that's for subtraction. So we don't need that. Example 5. So using the model from example 1, what is the residual of the baby that is 5 weeks old? All right. So residuals. And from what I understand so far this year, or so far today, you did not talk about residuals in Algebra 2 at all, right? Okay. That's okay. I don't think you're supposed to. I don't know if you're supposed to, but it seemed like I heard them talk about them, so that means, I don't know if they were considering or doing them or what. It doesn't matter. But what a residual is, I skipped all the words. Here we go. When we use a model to predict values, we expect our model to produce values reasonably close to the actual values. Like, we don't expect it to spit out actual values because it's real life stuff, but it should be reasonably close. That's the whole idea of a regression. And then this is the important part here. The difference between an actual value and the value predicted by the model is called a residual. It's very easy to find. All the residual is the actual value minus the predicted value. Y minus Y hat, right? And so actual minus predicted gives you a residual. Predicted minus actual gives you something else that we will get to later. Because really, this is from lesson 2.6, but because it applies to regression, we're just going to talk about it right now. So you've seen it, and then we'll talk about it when we get to 2.6, okay? But to remember what order to subtract in, if you subtract in the correct order, you do A minus P, and you're in an AP class. That's how you remember how to do it, okay? That makes sense? Okay. And because we're going to use residuals a whole lot more than the other thing that's backwards. So the right way is A minus P, okay? You're at AP. Not all of us act like it, but we are. All right, so then here, this was from the first example we did that you don't have to necessarily look at. We can do it without that. But so it says, using the model from example 1, what is the residual of the baby that is 5 weeks old? And interpret the meaning of this value. So the actual value, that means we're looking for W of 5. And if it's the actual value, it's coming from the table. What is W of 5? 4.4. Okay. So then W of 5 hat, my predicted value, which this was another reason why I liked putting the hats on them, because otherwise you're not distinguishing between the two things and whatever. It was, I don't know if that was the one we found or not, but it's 4.47. Okay. So then to find the residual, because here you see the line and then you see all the actual values, how far away a value is tells us some things statistically, which again, we'll talk about some more. But your residual is just A minus P. So that's 4.4 minus 4.47. Now, do you think when I subtract, I'm going to get a positive number or a negative number? A negative number, because the second one's bigger, right? That's how you get negative numbers. So when you subtract, you get 0.07, and I think it's kilograms, right? Negative 0.0. I just literally said negative 0.07. So this is the weight of the baby that's in the doctor's office. This is what the doctor uses to predict about how much the baby should weigh. And then this tells you how far off they are. And whether it's positive or negative tells us something. So sometimes just knowing if it's positive or negative is enough to tell us something, but they actually asked for the actual residual here, so that was important. So here's 5 weeks. This is the actual value, the actual weight of the baby. And then the line is the predicted value. So one of the things you're going to be asked for is it an overestimate or an underestimate? Well, when you actually have a graph to look at like this, it's pretty obvious, right? The graph itself, the function, is above the actual value, so it would be an overestimate, right? But the way you look at it, if you don't have a graph and you have this is where the negative comes in. If you have a negative value of a residual, that means the actual value is below the line. If it's positive, it's above the line. Does that make sense? And so that's kind of what we're looking at here as far as what to say. So we need to say, and let me grab this so I don't make this way too wordy. So the model is an overestimate of actual values. Now, is the model always an overestimate? No. Depending on where we are, here it was an underestimate. Here we were underestimate. So this is why we have to be more specific than this, because our statement right now makes it sound like it's always an overestimate. It's an overestimate. We only know for sure at one time, and that would be at t equals 5 weeks. Okay? And that's why you have to be specific about that type of stuff. All right, what questions we got? We good? You with us? No, you're not. I'll wait. You want to finish? All right. What questions do we have? Anything? We good? Oh, I'm sorry. Go ahead. Go. Well, I think we found it in example 1. If not, it's because I said so, but it's actual data. Did we find that? I feel like, no, we didn't. Okay. I didn't want you to have to go find it because I didn't want you to have to type everything back in again because it wasn't saved. So what we would have done is had this and not typed it in again, right? Because we never do that, but we would have found W of 5. And that's why I put number 4 in there. I just didn't think we needed to like type it in and do it again. Does that make sense? I should have been more clear on that, yeah. Because I just did it in my head. All right. Anything else? That was a good question. Yes, ma'am. If it's just asking you for what? Well, okay, and you have both. Is that what you're asking? Like, what would you answer? The question would specifically ask you either for the a predicted value or an actual value type of, like the wording would tell you depending on what it was asking for. Like if it asks you to use the model, because like we know what W of 5 is. We don't know what W of 7 is, so the only thing I can do is predict it, right? But at 5 weeks, I can get 2 different answers. And so if you can get 2 different answers, and you're supposed to give one, it should be pretty clear in the wording. That's a very good question. What else we got? Anything else? Okay, so remember, now if you click next, go ahead and look at your computers again. I think if you click next, I think I put a number 5 in there. Did it just lock because you had been out so long? It's not because you closed it, right? I'm just wondering. No, okay. Because I'm trying to avoid from y'all having to like close it open. If 5's in there, then you can just skip over 5 and leave it blank. It's fine. And then the next one should say worksheet number 1. So I'm going to give you the worksheet. And like I said, you need a place to work on it anyway, so here it is. And if you get your stuff typed in, and that's all you get done today, then it'll save it. I don't think there's a save key, which stresses me out on online stuff, but it does save it. And even though you haven't, and also at the end of Desmos activities, there's no submit, but I can see what you're doing all along the way. So, but it should still be there. So here is your assignment. And then remember in Delta Math, you can go type the stuff in, but I tell you it's a good idea to type in or to write down 4 decimal places because somebody else made this. Make sure you read at the top because it reminds you every time he made it, and I didn't feel like changing it. And it says, make sure you type in 3 decimal places, which is fine. So you wrote down 4, that's fine. Type in 3, just the first 3 you see, and you move on. Yes, and so like you can just do it all on here and then type it into Delta Math to check yourself. It's more there as a check. So they're literally, okay. Oh, wait. Okay, there might be, if you go in Canvas, there might be something that says Delta Math with 2 question marks. Ignore that. I didn't even know everybody could see it. That's when I was trying to play around with different things. So I don't even know if you can see that. But was there not a Delta Math assignment in Canvas? Has anybody looked? Okay, it's fine. I did assign it. Well, maybe I did. It doesn't matter because you can start with that. I won't double check. But it'll just be in an assignment in Module 1 for Unit 1. Okay, there you go. You don't have anything? Okay. And that's in your module. Okay. Yeah. Okay. So, thank you. I guess I don't know what happened, but, you can get it. My suggestion would be just kind of do it all anyway and then check yourself, but I will get it in there today. Thank you. So then my question is,